Homework S1 question 6. Part A. We've got a function fx defined as shown on the sheet, and we need to show that it can be rewritten as 1 over x plus 1. We want to start by factorising the denominator of this function, and x squared minus 2x minus 3 can be factorised to get x minus 3 x plus 1. Now the reason for that is because we can now see that we've got a shared factor here between this bracket, this fraction, and this fraction. So when I want to get a common denominator, I only need to multiply this one top and bottom by x plus 1. I don't need to adjust this one here. So that stays as 2x minus 1 over x minus 3 x plus 1. And this one can become x plus 1 over x minus 3 x plus 1. Now that I've got a common denominator and I can combine these, I can also expand this bracket here so that my numerator is 2x minus 2 minus x minus 1. Just be careful with signs when you're expanding that. Still over x minus 3 x plus 1. I can simplify the top. X minus 3 over x minus 3 x plus 1. So I now have a common bracket on the top and the bottom, which can cancel, and so this becomes 1 over x plus 1 as required. In part B, we're asked to find the range of f. A graph can be very helpful for that, so I've drawn a sketch of the graph of 1 over x plus 1. But we were told that this function had a restricted domain, and it only worked for values of x that were greater than 3, which is why I've drawn part of it with a dotted line and a solid line to represent what we actually get. As you can see, we very clearly have an upper limit here, so we need to find out what the value is when we plug in x equals 3 into that problem. Now plugging in x equals 3 into 1 over x plus 1 gives us an upper limit of a quarter, and because it is strictly greater than 3, then we need to be strictly under a quarter for fx. However, we still have the asymptote going across at y equals 0 that we normally would have for a graph of 1 over x plus 1. We don't have the negative part of the graph applying here because of our restricted domain, so this function is also bigger than 0. In part C, we've been asked to find the inverse function f, and we've been asked to state the domain of this inverse function. The easiest way to find an inverse function is to write it out as y as a function of x and make x a subject. Some people do prefer to swap the letters around at the start and make y the subject. I prefer not to do, and I'll explain why at the end. So I'm going to start by multiplying up by x plus 1, expanding the bracket, rearranging, and finally dividing. It's really important that we finish this question in the correct notation, and the correct notation for an inverse function is f minus 1 of x as a function of x. And that's why I preferred not to swap the letters over, because this function being written in terms of y hopefully serves as enough of a reminder that you need to make this change here at the end. Now we were also asked to find the domain, and the domain of an inverse function is the same as the range of the original function, and we found the range of the original function in part B. So I just need to rewrite that answer, but instead of writing fx, I'm going to write x for a domain. This is a follow-through mark, so whatever you would have had in part B can be applied for your answer in part C. In part D, we're given a new function g defined as 2x squared minus 3, which works for any real numbers, and we're asked to solve the equation f of g of x equals an eighth. Well, the first thing we need to do is we need to find the function f of g of x, which means we are going to substitute in this function g in for the x in f. So I'll start by writing 1 over, and instead of x, I write 2x squared minus 3, and then I continue on with the plus 1, and that is equal to 1 over 8. If I simplify that left-hand side, that gives me 1 over 2x squared minus 2 is equal to an eighth. Multiply up both sides so that I get rid of my fraction. 8 is equal to 2x squared minus 2. Add the 2, divide by 2. X squared is equal to 5. And so it would appear that my solutions are x equals plus or minus root 5. However, I have a restricted domain. Now g of x accepted anything, and x would only accept things that are coming out that are bigger than 3. Can I be sure that both of these answers are appropriate for my mixed function here? Well, in my opinion, the easiest thing to do is to look at the domain and range of each of those functions individually. So g of x is equal to 2x squared minus 3. That had a domain of any real number given in the question. And fx of 1 over x plus 1 also had a domain, but this time it was that x is bigger than 3. I need to look at the range of each of these functions. Now, we already found the range of fx. That was in the earlier part of the question, so we know that this should only give values between 0 and a quarter. But what's the range of 2x squared minus 3? Well, this is a quadratic, so the minimum value this can take is 0, and then we can take away 3 from it. So the minimum value that this function gets is minus 3. So our function is greater than or equal to minus 3. Now, if these two parts match, then we're all fine. We can plug in any value, and we're going to get out anything between 0 and a quarter, but these bits don't match. Now, what we don't have is values that this can take that this isn't creating. Every value that this function can cope with can be generated from here. So we don't have to change our range. We're only going to get values between 0 and a quarter, and an eighth fits in between those values. The problem we have is that this function generates values that this one cannot cope with. We need to restrict our domain here to make sure that we're not getting in anything that is smaller than 3. And that is why we need to check whether plus or minus root 5 will work in this mixed function. So what we actually have to do is we have to solve what is the inequality 2x squared minus 3 is greater than 3. Figure out what values of x are acceptable and what ones aren't. So if I take away 3 from both sides, 2x squared minus 6 is greater than 0, divide by 2, x squared minus 3 is greater than 0. That's the inequality that I have to solve. Whenever you solve a quadratic inequality, you should always draw a sketch. This one looks like this. Okay, and so I've got a value down here of minus 3, but I really care about the x values here of x equals root 3 and x equals minus root 3. And for this quadratic to be greater than 0, I need to be either bigger than root 3 or smaller than minus root 3. Positive root 5 is bigger than positive root 3, and negative root 5 is smaller than negative root 3, so both of these answers are acceptable. This was a bit of overkill for this question to confirm that we do have the right answer. I wouldn't expect there to be a trick question, but as mathematicians we should always check everything.